The Webb Telescope just found air on another Earth. This isn't just a headline for space fans. It's the first tangible proof that we have the technology to answer the oldest question in human history. Astronomers have officially confirmed the first ever atmosphere on a rocky exoplanet, and it means finding a true Earth twin is now a question of when, not if. But the gases they found aren't what you'd expect. They're the toxic fumes of a planet from hell. And that's actually the best news we could have hoped for. For decades, finding an atmosphere on a planet like our own was pure science fiction. We could spot the thick, bloated atmospheres of gas giants like Jupiter, but seeing the thin, fragile veil of air around a solid world? Impossible. It was like trying to see the skin on a flea from a mile away. The target was a planet named 55 Cancri e, a super-Earth 8 times the mass of our own, orbiting so close to its star that its surface is a sea of molten rock, with temperatures soaring over 3,600 degrees Fahrenheit. A hellscape. So why look for air here? Because if we could find an atmosphere on a world this hostile, it would prove our methods could work anywhere. But after years of tantalizing hints, the real question remained. Was the signal real or just noise in the data? This is where the James Webb Space Telescope's $10 billion price tag pays off. The technique is called transmission spectroscopy, and it's genius in its simplicity. As 55 Cancri e passed in front of its star, the JWST didn't look at the planet. It looked at the starlight shining through the planet's edge. If an atmosphere exists, certain colors of light get absorbed by the gases within it. It's a cosmic barcode. If you've ever wondered how we decode these distant worlds, this is it. And for the first time on a rocky world, the barcode scanned perfectly. The data was unmistakable. Webb saw the chemical fingerprints of carbon monoxide and carbon dioxide. This wasn't just a hint. It was a robust, stable atmosphere, likely bubbling out of the planet's magma ocean. The reason this is such good news? Finding this thick secondary atmosphere on a tortured lava world proves two things. First, that rocky planets can hold on to their atmospheres even under extreme conditions. And second, that the JWST is sensitive enough to see it. The training wheels are off. We've officially developed the tool to find Earth's twin. Now we just have to point it in the right direction. This discovery does more than just add a new planet to the textbooks. It fundamentally changes the game. The search for extraterrestrial life has officially shifted from a philosophical debate to an engineering problem with a clear roadmap. Scientists are now turning the Webb telescope toward systems like TRAPPIST-1, just 40 light-years away. There, at least 3 rocky planets orbit within their star's habitable zone, where liquid water could exist. Before, we didn't know if we could even detect an atmosphere there. Now, we do. We're no longer guessing. We are actively hunting for the specific biosignatures, gases like oxygen, methane, and water vapor that, in the right combination, could scream life. This isn't a search that will take centuries. The first results from these habitable worlds are expected within the next few years. For everyone alive today, this means we are likely the last generation to look up at the night sky and wonder if we're alone. We are on the verge of knowing. So, what do you think we'll do as a species the day NASA announces they've found a world with water, oxygen, and methane? This confirmation on 55 Cancri e isn't the final answer, but the starting pistol for the real race. We now have a proven method for finding air on other rocky worlds, turning science fiction into a concrete scientific mission. If you want to understand the next breakthroughs in the search for life as they happen, subscribe to Decoded Future. Our next investigation is closer to home. Scientists just found a way to make concrete that can heal itself, potentially saving cities billions in infrastructure costs. The future, arriving sooner than you think. The future, decoded.